Hello everybody and welcome to the video. Today we're going to focus on prime factors, greatest common factors, and lowest common multiples. This is going to be a multi-part video. I shouldn't even say multi-part, two parts. We're going to look at the skills in this part, then we're going to look at problem solving in the next part. Let's begin by defining some terms, just so we all have a common language. So the first term will be factors. Factors are numbers that when multiplied create a new number. So let me give you an example of that. So if we go 2 times 5 equals 10, then in this situation, 2 times 5 are your factors. All right, so they're the numbers that when multiplied create something new. Prime numbers. Prime numbers. Prime numbers are whole numbers that are whole numbers larger than 1 whose only factors are 1 in itself. Let me just add, sorry, that threw me off. I forgot to put whole numbers larger than 1. Anyway, so an example, what are two whole numbers that multiply to make 2? Well, the only way to do that is 1 times 2. Say something like 7. The only whole numbers that make 7 would be 1 times 7. How about something like 9? Well, with 9, you have 3 times 3, so 9 would not be prime. So prime is when this occurs. The only option would be 1 and that in itself, whatever number that is. Factoring. Factoring is the process of breaking a number or product down into its factors. So if I take something like 20, I could rewrite it as 4 times 5 because that still means 20. And this process of putting it into factors would then be factoring. So again, if I pick something like, let's say 45, I could say then, yeah, 9 times 5. And then that's my factoring. And you know what? I'm going to change something a little bit here. This whole thing is factoring. Perfect. Prime factorization. Prime factorization is the process of breaking a number or product into its prime factors. So it's just a half step further than what we just did. I can't quite remember what I chose. Let's say it was 20. That's 4 times 5. And then you can see here that 4 is not a prime number, but 5 is. So what we do is we break the non-prime down further. So 4 can become 2 times 2, and then the 5 just gets carried along. So these are factors, and that's handy in some cases, but other cases we like to go to prime factors. And in all the material we're dealing with today, we're going to be wanting to go to prime factors. So that's with 20. I remember the other one was 45. So 9 times 5. 9 can be broken down further, so I do it. 5 is prime. The only whole numbers that create it are 1 times 5. So I'm done. So again, these are just normal factors, basic factors. These are prime factors. There are a ton of different ways. Your factors can look a lot of different ways, is what I'm trying to say. I could pick something different like 15 and 3 for my 45 question I'm talking about here. But you'd only get one set of prime factors, one unique set. So no matter what this second line looks like, the third line is always going to be this here. By the way, I have no idea where that random yellow line came from. Let's keep moving. Now we're just going to find some prime factors. So there's a couple ways to do it. You can use a factor tree like you used to in elementary school, or you can kind of use a list method, which is simply the same exact idea. It's just it's updated a little bit because I'm going to waste a little bit less space. So let's begin with this one, 324. So when you're looking for prime factors, another way of thinking about it, just what are numbers that would, or to get these prime factors, just think about what numbers divide into 324. So the larger number you choose, the better, because it'll be quicker. But I know a lot of students, they're not confident with this, so they don't actually like doing this because their multiplication tables are a little bit weaker. So you can start with small numbers too. So typically I use bigger numbers, but for this video I'm going to use smaller ones, just maybe to mimic what you guys might be doing, or some of you might be doing. So the first thing I could do is I could rewrite 324 as 2 times 162. So I just took the calculator, divided it by 2, and I would have got 162. I can then just keep going with this pattern. I can go 2 is prime, so I just carry it down, but 162 is not prime. So 162 can be divided by 2 once again, and that equals 81. If it wasn't divisible by 2, I'd try 3 and I'd see what I get. If I didn't get 3, I'd try 4. Again, bigger numbers are better though. In this case, actually, it's not going to really matter too much. So I'll keep going here. The 2's are prime, so they get carried along. Sometimes I cross them out so I know I've dealt with them. And now I got to focus on 81. Well, 81, the first thing that pops up in my head is 9 times 9. And then I keep going till I get prime. So the 2 2's, they're prime and taken care of. 9 becomes 3 times 3. The other 9 becomes 3 times 3 again. And now I've found a list of prime factors for 324. If you want, you can write it in a power form to kind of save some room. So 2 squared and then 3 to the 4th, but you don't have to. Now, if you really want as well, nothing wrong with going factor tree just like this. If this just feels better to you, then do it. I really don't care. I just want you to get the right answer. But you can see, at least in my head, you eat up a lot of space this way. So that's why I don't prefer it as much. But if you want to use it, go for it. All right, let's try another one, 120. Okay, so anything ending in a 0, you guys, if you didn't know, let's divide that thing by 10. So I'm going to get 12 divided by 10. So that's bigger numbers than 2, right, and 3, which you could use, but if you can use bigger, use it. 12 then becomes 4 times 3. 10 then becomes 5 times 2. So one thing I may not have explained to myself is that the way this method works is I've written 120, and this still means 120. So it means 120, it just looks differently. That's what that equal sign is. So once again, it equals 4 can be broken down to 2 times 2. 3 just gets carried along. 5 is prime as well, so carried along. Same with that 2. So this last list here still means 120. It just looks different, and that different look enables us to do some things that we couldn't when it looked like a normal 120. Also, if you want to write it in a power form, you definitely can do that. Or you could use the factor tree. All right, let's try one more, 2,160. Okay, so anything ending in 0 we already talked about, we're going to divide by 10, so I get 216 times 10. Now, if you're familiar with some of your other division rules, they come in handy here. Like, we know divide by 2 if something's even. Dividing by 3, remember that if you add up the digits, so if I add the digits up here, 2 plus 1 plus 6, and see what that equals, it equals 9. If that new number is divisible by 3, then the original number, 216, is divisible by 3. So we can divide that thing by 3. Now, if something's divisible for 2 and 3, then automatically it's divisible for 6. So we know that too. So 6 I could try dividing by. But the thing what I want to divide by is 9 actually, because 9 has the exact same rule as 3. So if I add this up and whatever the new result is, so 9 in this case, if that new number is divisible by 9, which it is, 9 divided by 9 is 1, then I can use 9 as a factor. So I'm going to do that. So it's going to be 9 times 24 times 10. Again, we're just going to play around with your calculator until you get these numbers. The better you are at your multiplication table, the less you'll need your calculator. And then we're going to keep going. So 9 is not prime, but I can factor it into primes. 24, I'm going to say 6 times 4. You could say 8 times 3. That's fine. In the end, we'll get the same numbers. 10, 5, and 2. All right, carry my primes. So boom, boom. This is now 3 times 2. This is 2 times 2, 5, and 2. And I'm done. And again, if I want to write as a list of powers, 2 to the 3rd power, that's 1, 2, 3, 4. Sorry, 2 to the 4th. And then 3 to the 3rd, 1, 2, 3, and then my 5. But you don't have to do that. That is okay as well. It is nice, however, for me correcting in things. If you write it like that, it makes things a little bit easier for me, but I'm worried about you getting the right answer, not things being easy for me. Now let's look at greatest common factors. So greatest common factors, we're going to use these prime factor skills. So first of all, what is a GCF? Well, a greatest common factor is 2 ways of looking at it that I'm going to present to you at least. It can be the largest factor that exists within both numbers. So if you're looking at 2 numbers, maybe the largest number that's common between them is 7. So that would be greatest common factor. The other way of looking at it is the largest number that can be divided into both numbers. So however you want to wrap your mind around it, that's the greatest common factor. Let's look at how to find a greatest common factor. So we looked at prime factors for a reason, and that reason was we have to use them. So the first thing we're going to do here to find the GCF is actually find the prime factors of the numbers in question. Once we have the prime factors, we'll do something with them to help us generate the greatest common factor. So 24, I'll say 12 and 2, this for variety here, 4 times 3, 12 becomes, and the 2 gets carried down. 4 isn't prime, so I'll write as 2 times 2, and then I can carry these other two numbers down. Perfect. And let's look at 60. 60, I'll say 15 times 4. 15, I'm going to say is 5 and 3. 4 will be 2 times 2. Okay, so I have the prime factors for these two numbers written out. The second step is you want to create a common factor list. So what are the common factors? So common means numbers that are in both lists. And if there was 3 numbers, common would mean numbers that are in all 3 lists. So you have to have the number present with everything, with every number that you're testing, I guess. Okay, so I see that there's a 2 common, another 2 common. Also, there's a 3 common to both. So I'll make that list 2, 2, 3. So I just mentioned the number once. So if it's in both numbers, I write it down once. The third part is now we actually create this GCF, and the way we do it is we simply multiply the numbers. Whoa, I kind of wrote that out of order. I simply multiply the numbers in the list. So 2 times 2 times 3, so that would be 4 times 3, or 12. So 12 is the greatest common factor of 24 and 60. Let's do that again with slightly larger numbers. So again, first step, prime factors. So 540 ends in a 0, so I know that's pretty easy. 54 times 10. Again, finding the prime factors is often the worst part about doing this. If you're comfortable with multiplication tables, you're not going to think it's that bad. But if you don't like multiplication tables, you're not a fan of this process. But don't worry, you can use your calculator to help chip away at it. Anyway, getting back to this. 54, I'm going to say 9 times 6. 10, I'll say 5 times 2. 9 then becomes 3 times 3, and that's prime, so I'm happy. 6 can become 3 times 2. 5 is prime, and then the 2 is prime. Now notice I'm not worrying about ordering it and putting it in that powers list. I know I'm going to use this information for another step. It's not the final answer or final step, so I'm just going to leave it as is and move on. 900, 90 times 10, and then 90 becomes 9 times 10. 10 becomes 5 times 2. Keep going. Okay, 9 becomes 3 times 3. 10 becomes 5 times 2. And then we have 5 times 2 and 5. Oops, I mean just 5 times 2 one more time. Okay, I'm just going to scan that. 3, 3, 5, 2, 5, 2. All those are prime, so I'm done that part. I want to make my list. All right, what's a number that's in both lists? Well, I see a 3 and a 3. Another 3 and another 3. I see a 2 here, a 2 here, 2 here, and a 2 here. Then I also see a 5 is common. So there's a lot of common pieces in this one, common factors. So again, my list, I just write, for every time something's common, it gets written down once. So 3, 3, 2, 5, 2 would be my list. And then the third step, I'm going to make this GCF. And you can, of course, you guys, when you're doing this, you don't have to show all this work that I'm showing. You can show it in a more concise or smaller form. So this now becomes 3 times 3 times 2 times 5 times 2. So 9 times 10 times 2. That's 90 times 2. So 180. 180 is the lowest common multiple for 540 and 900. So let's look at the steps for this. I know I wrote it out, and I hope I present it in a decent form. You can see those steps. But the first thing we want to do is determine the prime factors. Then we want to find the common factors between the numbers in question. Again, if there was 5 numbers in question, then a factor would have to be common to all 5 lists, just so you know. We can't leave anything out. And once we have that list, we multiply the common factors to create the GCF. All right, the third and final thing we're going to look at in this video is lowest common multiples. All right, first of all, we should talk about what a multiple is. I think the nicest way to talk about it is a multiple occurs when counting by a certain number. So an example, if I count by 5s, 5, 10, 15, 20, these are all multiples. Let me change my color here. These are multiples, and they happen to be multiples of 5. So when I count by certain numbers, I create multiples. I think that's the easy way to talk about it. Now the least common multiple, or lowest common multiple, it's the first number that appears in both sets of multiple lists. So I'm going to look at a different technique than this, but if I said something like 5 and 10, ooh, my pen's not working here. There we go. And you know what? Instead of those two numbers, I want to change my mind. Okay, and I wrote 7, but I actually didn't want 7. I wanted 3 and 4. Those add to 7, so I think that's what I was thinking. Sorry about that. If I count by 3s, 3, 6, 9, 12, 15, and I count by 4, 4, 8, 12, 16, you'll see that there's a number that appears in both lists. And the first time you see a number like that, that becomes the lowest common multiple. So in this example, the lowest common multiple is 12. So these lists, you can always use a list like this. It's just when the numbers maybe are larger, the list can get difficult or really long to create. So we're going to look at a different technique to help us. So let's start that right now. Example 3, determine the lowest common multiple. Well, we begin a familiar way, everybody. We're going to find the prime factors of these numbers. So prime factors. 12. So I'm going to say 4 times 3. The 4 becomes 2 times 2, and then times 3. So I'm done that one. 15. I'm kind of picking some easier numbers here because I want to focus on the process. If I pick tough numbers in the start, you might be intimidated by the actual factoring or something here, and then you kind of lose sight of the process. So if you're wondering why we're picking kind of nice, easy numbers, so I can focus on the steps. Yeah, and 5 times 3, so that's prime right away. So we find our prime factors. We know that's just something you have to chip away at. What we do next is sometimes hard to put into words, but it's easier to show. To determine the lowest common multiple, we first of all select each type of factor that we see, like each different type of number that we see as factors. So I see a 2, and I see a 3, and I see a 5. So those are all the different types of numbers that were in my prime factor list here at the bottom. And then what I want to do is I want to pick out the greatest power of each type that I see within one number. So, like the greatest power, or I want to determine which one has more, say, 2's, and then how many 2's. So this one has more 2's. You can't see me pointing, but this one has more 2's, and it has 2 2's. So I'd put now 2 squared in my LCM list. I'll choose green here. 3's, well, there's a tie. There's a 3 here and a 3 there. So we don't add them together. We just see what's the greatest power of 3 within each number. Well, this is 3 to the power of 1, and this is 3 to the power of 1. So 3 to the power of 1 is the greatest power that I will that I get. So I choose that number. And then now 5, there's only one 5, and it's 5 to the power of 1, so I put a 1 up there. Once I've chosen those numbers, I simply multiply them together, and I will create the lowest common multiple. So this is 4. That'd become 15. So 60. 60 would be my lowest common multiple. If I wanted to, which I don't really want to, but you know what? I think it might be helpful. I can make my list, so I'm counting by 12s there. Now I'll count by 15s here. And you can see 60 is indeed the first number that appears in both lists. Now you might be thinking, why not always use the list? Like I said before, the list method can get long or can get kind of annoying to work at when you're working with bigger numbers. This lowest common multiple idea, it's always about the same amount of work. So it's just these 2 steps, but you're right, the prime factorization, breaking them into primes can be maybe a bit longer sometimes, but overall, I really like this technique. Let's do another one. Okay, B. 40 and 72, we want to find the primes first. So 40, that's a nice one again. I'm going to say 8 times 5. And then I know 8 can become 4 times 2. So I'll just do that. I was going to do a bit of a shortcut. And 5 is just prime. 4 is in this 2 times 2, and then I carry down the other primes. I often go from 8 right to the 3 2s because I know that's always the result. 72, 9 times 8, so that's 3 times 3. And then like I just said, 8 becomes 4 times 2, and the 4 becomes 2 more 2s. So 8 is really equivalent to just 3 2s being multiplied in a row. And again, reminder that this is 40, and this also means 40. It just looks different. So this means 72, and this means 72 as well. So we haven't changed anything except the look. It's the same value. Okay, second step, lowest common multiple. Okay, once again, I want to pick each different type of number I see. So I see that there's 2s in this question. I see that there's, and I'll put my little box for my exponent. I'll put 3s. And then I'm going to put, there is 5. So if I saw other types, I'd put them in the list. Okay, the 2s. So I see 2s here. So this is 2 to the power of 3. I see 2s here as well. This is again 2 to the power of 3. So I just pick the largest number I see. So 2 to the power of 3 is what goes in my list. I don't add those together. Okay, 3. I see there's 3 squared in that question. There isn't anything in the other one, so automatically that's 3 squared. And then 5, there's only one of them again, so put my 1 there. Now that I've made my list, I simply multiply. 2 to the power of 3 is 8. 3 squared is 9. That's 5. So 72 times 5. And then 72 times 5, you can do in your calculator or in your head. You get 360. So that's how we find the lowest common multiple of those two numbers. Again, if you really want to, you could count, you could make your list. And before, I almost signed off on this one, but before I move on, there's 40, 80, 120, 160. Like, I'm going to get there. I just don't feel like doing it, but eventually I would get there. Same with 72. 72 is kind of uglier to count by. Like, I don't feel like doing it again, but I could do that. I would also get 360 in both lists. Okay, let's do one where we have 3 different numbers. The steps don't change. It's just we, unfortunately, have more numbers floating around. I shouldn't say unfortunately. Some of you likely don't mind that. Okay, so 12, I'll say 6 times 2. And then 6 becomes 2 times 3. And then I have that additional 2. 360. That would be 36 times 10. And then I'll say 6 times 6. And 5 times 2. And then the 6 will be 3 times 2. And then another 6, 3 times 2. And then 5 times 2. And one more to go, 50. That's a short one. 25 times 2. 5 times 5 times 2. Again, even if these were big numbers, we'd take our time and just find the prime factors. So once we have those prime factors, now let's make this LCM. So look for all the different types of numbers. I see 2 as a factor. I see 3 as a factor again. I see 5 as a factor. Now again, this part's going to be familiar because you're looking at prime numbers. So 2s, 3s, 5s, 7s, like they're the numbers that you're going to be seeing. Okay, let's check out the 2s. So in this one, I can see 2 squared. In this guy, I can see 2 cubed. And in this one, oops, I see 2 to the first. So 2 cubed is the biggest number I see, so I choose that. 3, I see that's 3 to the first power. 3 squared there. And 50 doesn't have anything, so squared goes there. 5, that's 5 to the first. This is 5 squared, so 5 squared is the biggest one. We choose it. All right, so I've made my list. So now really I have my answer just kind of in disguise. So let's take it out of its disguise. Let's just actually multiply. So 8, 3 squared is 9, and that would be then 25. Well, you know what? When I see 8 and 25, I know that 4 sets of 25 make 100. So 8 sets would make 200. And then that's 9. And then now 1,800. So again, that really didn't take much more work than our first example. But if we were to make a list, it would be a super big list, because like, you imagine counting by 12s up to 1,800? That would take forever. So that is why we wanted a different method besides that list method. Okay, so that's, sorry, it took a second there. That's the end of this video. So that's all our skills. Stay tuned for the next video where we look at some problem solving with these skills. Okay, have a great night.